Oh, we're back. Look at that. Hopefully that gave you enough time to fill out the questionnaire we have on AI agents in production. Now I have the great pleasure of introducing our next guest, one of which is amazing. The other I can't say the same for, because if you're ever in a place and you want to eat and you're around this speaker, I highly recommend you protect your food. I was here last year doing the same conference, and I got off the stage only to find that he had eaten my sandwich. So let me welcome to the stage the thief himself, Ioannis.
Here I am. That's yours, right? Hi, hello, thanks.
Get out of here.
Thanks. I didn't know, but actually he's Greek, so I like his food. Well, what we're gonna talk now, in the previous discussion, Euro and Paul talk about OLX Magic and Tokan, and I would like to focus on bringing Tokan agent, data analyst agent into production, and our journey through this. So I will start with, where's the presentation? Oh, perfect. Right. So first of all, I would like to start with introducing Donné. Hi, Donné. Nice. All right.
Hi.
Let's start. Presentation. Right. Okay. Good. So from agents to product, bringing Tokan, data analyst, to hundreds of users. Who we are? Well, I'm Ioannis. You just met Donné. She will take care over the presentation a little bit later, so I will invite her again. First of all, what is Tokan Data Analyst? I think Euro and Paul described it before, but very, very plain. It gives you the opportunity to ask a question in English and got back an answer. In essence, it does all the work for you. It translates your question into SQL. You get back the answer, and then you can even visualize and see the results. So that's what we are trying to go live the last couple of months, and what we want now to share with you is our journey. Before we dive in, agents are really magical, right? So I think everybody has this kind of moment where it says, wow, this is very good. This is what we have also experienced. You ask a question, it understands the question, it finds the relevant data source, it can generate and execute SQL, it recovers if it fails, and that's one of the advantages of using an agent, and it gives you the results, and then you can even get visualization, so it's very, very nice when it works. Because truth be told, it never works out of the box. And you can go through many moments like Donné here, where it asks the agent to stop, and the agent simply doesn't do anything. He just continues again and again. And you stop again, you ask again, and then you get the same answer. So another way is that, well, instead of doing something, it starts giving the same answer 59 or 58 times. So in essence, it can get very, very, very frustrating. So what we would like to share with you, and why I want Donné to give this, explain what we have learned, is in essence how you get from a product which is keep failing to a product which is actually having an adoption, as you can see here on the screen. And there are actually 4 things where we have learned and what we would like to share with you. So first of all, we want to make sure that when you are solving for an agent in production, you need to be able to solve behavioral problems using deterministic flows. First. Second, you need to make sure that you leverage your experts to set up and monitor your agent. Third, you need to have a system that is resilient enough to handle any input. And fourth, you need to make sure that you simplify the work for the agent by optimizing some of the tools. Now, these are 4 lessons that we have learned working with the agents the last 6 months with this particular agent in production. And I would like to invite again Donné to walk us through for each of these 4 lessons and help us understand how we actually implement this. Donné?
Hello?
Hey, hi.
Hi. Okay, am I on?
Yes, we can hear you.
All right. Cool. Great. So I can see the presentation now, great. So thanks, Ioannis. Hi, everyone. I'm Donné, and I'm one of the machine learning engineers who worked on developing the token data analyst, along with some of our development partners in the Prosus portfolio, so like iFood and Glovo and OLX. Yeah, so these 4 lessons that Ioannis has kind of laid out, that's kind of the framework for the talk. And for each of these lessons, I'm going to go through the challenges we were facing and the solutions we put in place to deal with them, and how that kind of ties back to an overall lesson for an agentic framework, and more specifically for developing these more verticalized agents. So yeah, let's just go to the first one. So to solve behavioral problems, consider deterministic workflows. Agents are great, right? So especially large language models, they can generate quite a lot of text, but it can be a little bit unpredictable. And when we first started building the agent, we had this sort of idea in our head that when users were asking questions, they would ask a question and the agent would be able to determine, can it answer the question? And this is specifically for when you're thinking about like SQL, which there's a lot of context. Context matters when you're writing SQL queries, because you need to know the rules of the business and you need to understand how the different data is used with that. And ideally, the agent should know and be able to say, oh, I don't actually know enough information. But what we found in reality was users would ask vague questions, and the agent, and this is a large language model thing in general, would produce an answer. And it wasn't always a good answer. These answers could be just straight up wrong, or different runs would result in different answers because there was an ambiguity and perhaps multiple ways to interpret the question. So we had to find a way to solve this. And because it was a required behavior, right, we knew the agent needed to go, can I answer this question given the information I have right now? And because it was required, we could hard code it. And so we implemented the sort of pre-processing step, which would evaluate the question in isolation, so just the question and the context, before the agent ever got to try and solve the problem. And by doing this, we create a more consistent experience for the users, and also a more reliable system, because we know that it will stop when it doesn't know enough. And these sorts of deterministic workflows, they can kind of help in a lot of different ways. So here we've managed to make the experience more consistent, but there's also other ways we could use it. So one of the other ones is when generating the actual SQL queries. In an ideal world, the agent would produce perfectly valid SQL that only referred to information that was actually available in the table documentation. But I think, and you can think about this as like a normal data analyst, right? You might go over the schema and the table documentation once, and then from memory try and write the different queries. And you might misremember the name of a column, maybe put in like a spelling error, or maybe even like assume the assumption of a column because it would make sense just sort of given what you know. And no one's going to go back and check the schema immediately, right? You run it and you wait to see what happens. And our analyst was doing exactly the same thing, and getting back these column does not exist errors. But this was a predictable error. We knew that this would happen. So why were we waiting to run it against our users' servers, which meant we were making, one, a call to our users' systems, putting unnecessary load over there, but we were also wasting quite a few cycles of time trying to get an answer back before we would try and correct it. And it was a case where we could predict that this would happen. So again, we put one of these predetermined steps in place where when a query is written, the first thing we do is check, does the column exist, right? And we can then bypass an entire set of agent flows to say, okay, you can't answer this question with this query, and immediately start problem solving from there. So the idea is basically the agent can produce a lot of content, but this LLM content can be evaluated and it can be simplified if we're using good functional problem solving to check it before we start applying it out to the outside world. And this will reduce the number of unnecessary cycles that the agent's going to have to do to problem solve, and overall just make the process a lot smoother. Thank you. The next one is leveraging your experts to set up and monitor your systems. I think with agents, or LLMs, we're so impressed by how much they can do, and once you have agents, how quickly they can problem solve. And the answers are always sort of human understandable. And so I think sometimes forget that these still need to be treated as data products. And so they need to be tested, and they need to be tested rigorously when you're building very specific and very specialized agents like a SQL analyst. And when we were initially building out the idea for this agent, we did a once-off transfer with our data experts. So they would give us documentation, they would give us schema, and we would take that in, we'd ingest it, we'd figure out how to store it, how to feed it to the agent, and then try and solve the problems with the test sets we were provided. We would send this feed or the results back, and then our data experts would come back and say, no, there's a problem, the answer is wrong, it's missed this detail. And we would then take that feedback and we try and fix it. But we weren't experts. We couldn't figure this out for all the problems on our own, and we couldn't make general solutions that would fix such specific problems because it was different for every use case. So we had to find a flow that would let us include our experts in the process of developing the agent. And so we've created pipelines and UIs for the experts, the data experts who are using the agent, to kind of update their documentation so they can move really quickly in like their development cycles. They can move without our intervention. And because they can do this, they can optimize the documentation that they're building up for this agent to be consumed by an agent rather than by a human. And by doing that, their agent's also becoming really specialized and really good at their specific use case. So, ready for production. We've done a lot of testing. I think we'd gone through a lot of processes of figuring out how to optimize certain things. And part of the process was for us to understand what the token data analyst's role was, what it could do and what it couldn't do. And to some degree, you kind of assume everyone knows that when you call it a data analyst. It's built to do data extraction and it's built to kind of evaluate that data. But the moment we gave it to users who hadn't been involved, but who were familiar with Token, they started asking questions we sort of hadn't anticipated, that we weren't prepared to deal with, and just queries we really just didn't know what to do with. And occasionally there was also a little bit of abuse for poor Token. But realistically, when we're building products like this, users pushing the boundaries of what your product can do, that shouldn't be a problem. There's Postel's law, it says, be conservative in what you do, be liberal in what you accept from others, right? So this is out in the world and users are going to push, and it's good because it's also how we start to see new ways of using these things, but we also have to have the system be resilient enough to handle it when they're pushing past either what we expect or what the agent can actually do. The big lesson here for us was how to mix hard limits, so like really specific rules about when the agent has to stop, with soft limits, which are more, how can we sort of point it in the right direction? How can we nudge the agent into the path we wanted to take without removing the ability for the agent to do creative problem solving, to self-correct, because that's why we use agents the way we do. And by finding a way to balance these two, we did find a way to keep the agent capable of problem solving, but not get trapped in infinite loops with itself or in rabbit holes that ultimately wouldn't answer the question that the user had asked. Okay, cool. We'll hop to the next one. Yeah, cool. And then the last one, optimizing tools to simplify work for the agents. A lot of the lessons we learned here were about how to set up the main agent flow and how to set up control mechanisms within that flow to help the agent as it moves through the problem solving. But one of the big parts of an agentic framework is the tools. And so when you're trying to optimize an agent to do good work, optimizing the tools is a good way to start putting good control mechanisms in place. One of those for us was the schema tool. So the schema tool is used to read the documentation and then determine what's relevant for the agent to know in the main context. And the schema tool initially was relatively broad because we had very small use cases with only a couple of tables, and they were relatively small tables. And what we found as we developed and we got more and more use cases was that this tool needed to get better at determining what was relevant for the agent to know. And the value of doing this meant that the agent was getting very concentrated information. So it couldn't get distracted by wrong information and didn't have to pass the context for information that wasn't relevant to it. And so this tool was reducing the effort and the complexity of the problem that the main agent had to solve. We are now trialing out a similar thing with the tool that does the SQL execution. If you've ever written any SQL, you'll know that, the first couple of SQL queries you write, they make generally errors that are not very context specific. They're general errors. If you're moving between different SQL dialects, things like date functions will sometimes get confused. And you don't need to know too much about what's happened before. You don't need to know what's happening outside of really anything other than the SQL you're writing to fix it. And we're letting the SQL executor try and fix that itself before going back to the analyst. And this optimization is, again, saving these cycles between the agent and the tools, which makes it faster, but it also means that the agent's context is not being cluttered with bad information. So the key takeaways here are basically when these tools were being built, it made sense to move fast and limit the complexity of them so that we could check the feasibility. But as we scaled, it was important that these tools were growing with the agent to become smarter at how they shared information.
How much
to
more
really
time?
allow the agent to focus on the main
This is real because
problem.
it changed. The time. It's changed. The time changed.
Did I miss something?
No.
Cool. Not sure. I'll wrap up quickly. So those are kind of the challenges. And then just to kind of reiterate, they kind of turned into these 4 lessons about using deterministic workflows, always keeping experts in the loop, making sure the agent system is resilient, even though it can problem solve. It doesn't have to problem solve everything itself. And tools are a good way to optimize agent workflows. One last statement. AI first doesn't mean AI only. And I think that is it. On to the questions.
Yeah, perfect. Thank you. Thanks, Donné. My Greek friend. You want this?
Yeah, give me this.
Questions? Okay. You also want that?
Before you steal it, like you stole my sandwiches. All right, so luckily, Donné was here to give some really quality stuff.
I know. That's why I invited her. It's Donné, but of course it was a team effort, right? It was Donné, Floris, Sean, Mark, Nick.
So many. Yeah.
Many, right? So
except for you. So now, there's a lot of great questions coming through. You can see them here. I'm looking at them here. First one coming up is, can you give us an example for the reflection tool and how you built the logic in there? Who wants to go?
Donné?
Donné?
Yeah. Good. So the reflection tool actually was implemented, and it was the idea of Floris, who is also working on the SQL agent. It exists within the execution tool. Sorry, there's a bit of feedback. And it's essentially just an additional call to an LLM, right? But it's a much, much smaller call because all we have to share is the query and the error. And it can immediately return a response that we can then try and fix from there. So it's an extra step in the existing tool.
That was your amigo here talking while you were trying to talk, just to let you know. Just keep talking, Donné.
This is just standard for him, right?
It is. It's not anything off par, right? So there's another great question coming through here. That is, how did you, and this is specifically for you. Yeah, so obviously, I don't know what he's still doing up here, but how did you minimize abuse of the agent? Did you include potential tool abuse in the testing phase prior to the release to prod? Good question.
So I'm assuming tool abuse is looking at things like running many tools or running tools kind of infinitely long, especially when you're running SQL queries, right? So we run SQL queries against user databases. So one of the big risks is that we run queries that ultimately lock up those databases. And there's a couple of mechanisms in place. We have timeouts, so tools can only run for so long. And we have like pretty strict requirements with the guys we build that when they give us credentials that we have relatively limited access so that any mistakes would not sort of bring down their broader systems. And up to this point, the biggest issue we've had is infinite tool calls, and that's easy, right? That's a hard limit. If you're running too many tools, stop. So there's a couple of places you put it in, but I think especially when you're dealing with SQL, it's important that your access is limited so that the agent can't sort of DDoS it.
Yeah. So before I ask my amigo here one more, the big question that I have is how do you make sure that the agent has proper access to the data and the database? Like, how do you have the role-based access with the agents?
It's a good question.
So this is difficult because every user has like different databases, and then the way they're managing access is very different for each of them. So the access is managed on a case-by-case basis, and we will work with the guys who are in charge of the access to figure out the best way to let us connect. And then, yeah, there's obviously like secret management that we have to do on our side as well. But every case is different, and we do have to have quite a few different managements for that.
All right, so this one's for you.
Oh,
Ready?
hard.
What framework have you used?
Actually, from the beginning for Tokan, we have started developing our own framework. So we haven't used any of the frameworks that are out there. We have tried a couple of them. I think a colleague also yesterday gave a talk about the different kind of frameworks. But we have found out that for what we actually want, it fits better our own goals to use our own framework. That doesn't mean that there are no frameworks out there, that they are working well. It's just that it's a very exploratory space, and I think it also pays off to explore what you can build in terms of your own capabilities, because you also don't know how you need to shape it in the future.
But did you play with any frameworks to see how they work and what they do?
We have tried in the beginning, but it was very early, so we didn't really stick to it. And now we are only trying as a kind of like a swarm for education, right? So to try things and see how it works, what are some of the pros, what are some of the cons. But so far, I think that the framework that we have built is very powerful.
Yeah, also you started Tokan 2 years ago, right?
Yeah, exactly.
So the frameworks 2 years ago are much different than probably what you're getting today, so you already invested.
Exactly, we've already invested and we have tested and it scale in terms of numbers and requests, and now going and testing another framework, I don't think so there is a payoff at the moment.
Yeah. So which mechanisms do you use to determine when the agent should ask for clarifying information?
Donné, do you want to take it? I can also take this, but I think it's good to take it.
Sure. So the mechanism is what we call a pre-processing step. And it's essentially, these pre-processing steps can be pure functional work, or they can be smaller requests to LLMs with much shorter context and much smaller expectations on the kinds of responses. And in this case, it's that. So we share the available context or condensed version of the context with the question, and essentially just try to determine, is the question answerable given the context? And just small shout out to ProLLM, the data set that we use to analyze the model for this is also being tested in ProLLM.
Yeah, ProLLM is a gem of a resource on the internet, so huge shout out. The next question, and potentially last question, depending on how verbose you are, is Tokan based on a single agent, or are there multi-agents communicating amongst each other?
I think it's a single agent that it can be very easily transformed into a multi-agent. In essence, data analyst, Tokan data analyst is a part of Tokan, right? So in that way, it's a vertical agent of a horizontal agent because token can do many different tasks. Inside this token data analyst, we have separate tools that we are invoke, right? That we are calling. So strictly speaking, is a single agent. If you're going to lose a bit the definition of the agent, then you can also consider it to be to have some flavors of multi-agent.
So for the inference, you're using how many different LLMs, and what are you looking at? Open, closed source? Are you primarily hitting one first, and if it can't do it, then you go to something else? Do you have a proxy that will tell you for like the scaling and rate limits, all of that fun stuff?
For token, we are using different models. Some we have tried a lot.
Yeah.
Some are closed, some are open. We generally decide to choose the model that performs the best. So
This is the best non-answer. You're a diplomat right now. We use some open, we use some closed.
I mean, I can tell you
we like the ones that perform the best.
We use the ones from the best.
All right, you use the best models. There we go.
We use the best models. We use the best models. We use
which are
most of the time OpenAI.
Okay.
Models, but it doesn't mean that we use the same model for the whole flow.
Okay.
Right?
Tell me more about that.
Yes. So we have separate tool calls, right? For example, you have the reflection tool, like Donné said before. You have maybe a pre-processing step, and that can be deterministic. But if this is not deterministic, you might use another LLM there to make a call. So it depends on the complexity of each tool. We can call different type of model. We can call mini. We can call the 1.0,
Yeah.
01.
Yeah.
We can call 4.0. We can call even GPT-4 Turbo.
Yeah.
Right? So it depends on the complexity. It depends on the cost. These are the two main requirements.
Which are more complex versus less complex? Which of these steps? When can you get away with the small models?
I would say that the execution component is the one that it's more complex. Smaller, more sliced tools are much more easy to use smaller models. Generally speaking, the data analyst doesn't use very light models. So it's quite heavy in terms of computation, and also the cost of error is very high. Right, so because people are depending on the analyst to get back data, and they take decisions based on this data. So the risk of making a wrong decision, right? So we are optimizing for precision, and that's why we don't want to take big risks on what type of models do we use with that they might possibly underperform versus the state of the art.
Brilliant. Man, this is very, very cool. I think we just hit time, so that's it. Sadly,
I'm gonna eat the pizza.
Yeah, actually, there's a party going on here upstairs of the Next Museum with everybody that came live. And if you're in Amsterdam, you still got time. Come. If you're in, even if you're in Belgium, come and we can make it. So we're here all night. But for those that are virtual, we've got you set up with a video that's going to happen right now. And then we're going to get right into the next talk shortly, I guess, is the best way to describe that time frame.
Thank you. Thanks, Donné, and thanks, everyone.